Welcome back, guys. This is another video on the periodic table. I'm going much more into depth. In this one, I'm really going to explain it. Okay, so this is the periodic table. This is the basic layout. And first thing you should know is periodic. Periodic means repeating. Okay, so the periodic table is a very important tool and very useful tool because it organizes the elements. Okay. Back in the day, I'm not really sure when this was put together. I think it was like about 150 years ago. Scientists were coming up with all these elements they were discovering, right? And they didn't have a way to organize them. So there was two guys that they actually organized them into similar table, really. And what they did was they put the elements in order of increasing mass, because at the time they didn't know about electrons and protons yet. But really, now these are increasing number of protons. This is 1 proton, 2 proton, 3 proton, 4, 5, and so on. Okay? And now, as you know, with increasing protons, you have increasing electrons, because in the stable atom, as in these here, the number of protons matches the number of electrons. Okay, now, yes, some terminology. These rows are called periods. These columns are called groups. There are 18 periods and 7 rows. Okay? I'm sorry, I said that wrong. There are 18 groups and 7 periods. Now, one thing that you will notice is this detachment here. This detachment really just fits in this slot and extends the periodic table, but for the purposes of fitting it onto a piece of paper, onto your textbook, then they just remove that piece and place it here. But really, it goes in this section. Now, one thing that is just in the nature of electrons, of atoms, which makes sense, is this this layout that we have for them. This ring, this one here, is called an orbital. Okay? And the number of electrons that can be in a certain orbital, because you have the nucleus, and then you have an electron, okay? And then you have more electrons. Because they don't all spin around like crazy. They have sort of a structured way where they can spin, okay? Later on you will learn much more complexity of how they actually are shaped in 3 dimensions. But this is the 2-dimensional model we need for now to explain bonding, okay? So the number of electrons that can fit in this orbital, actually, it's easier to explain that this orbital matches to the periods. So since we know there's 7 periods, then there are 7 orbitals. Okay? This is actually fluorine, which is denoted by F. It has 9 protons. It is about right here, number 9. 9 protons, 9 electrons. It is in the second row, therefore, most of these electrons are in the second orbital. Okay. Now, what we notice is that once it gets to this one here, it adds 1 more. It gets to 10. It fills up its orbital. Okay. At that moment, it is stable. Okay. These elements here have full orbitals. Okay. These elements are inert, means they don't react. They don't react very much. Okay? They're stable. So atoms naturally want to go to stable. That's one of the things that you should start noticing in chemistry. Most of nature wants to go into a stable, more lower energy state. And atoms do that by completing their completing this shell. Okay, that's actually how it's called, electron shell. Okay, this one needs one more to complete that that number of electrons. Now let's look at this one. This is lithium. Okay, Li. It has 3 protons. It is situated about right here, number 3. Okay, and this one you can notice it has 1 extra. For this to fill up its orbital, it has to gain 7. Okay, but if you think about it, it's a little easier for it to just lose 1. Lose 1, it goes back to 2, right? So then it just has a complete stable orbital. Now, this is what happens in bonding. This one wants 1, this one wants to give 1 away. So what happens is that this one gives it away and this one takes it. Okay? In that process of giving away and this one taking, this one becomes negative and this one becomes positive. Okay? So lithium 1 plus, fluorine 1 minus. Okay. Now, because these are opposite in charges, they attract each other. And this type of attraction is called an ionic bond. Okay? So really, if I were able to move the orbitals would overlap. Okay? Sharing the electrons. Really, the pull of this fluorine is so great that it pulls the electron completely away. And that's what you call an ionic bond. Okay? Because like I said, mentioned in previous videos, this chemistry, these bondings, there's different types of bondings. And now, when the electron is completely ripped away, it's called an ionic bond. Now, when the electron